Hi guys, I'm Ramin Magboo. I'm from IT 2102 and today I will discuss or I will tackle about the chapter 2 in CNA 1 entitled the network access. Network access. It is to support our communication. The OSI model divides the function of a data network into layers. Each layer works with the layers above and below to transmit data. Two layers of the OSI model are so close tied that according to the TCP or the IP model, they are in sense one layer. Those two layers are the data link layer and the physical layer. The physical layer. The OSI physical layer provides the means to support the bits that make up a data link layer frame across the network media. This layer accepts a complete frame from the data link layer and encodes a series of signals that are transmitted onto the local media. This is the physical layer media. This is have the copper cable, fiber optic cable, and wireless. What is copper cable? It is the signal or patterns of electrical pulse. It is this. And the fiber optic cable, it is the signals of light. It is in the center. And the wireless, the signal of patterns microwave transmissions is the microwave signals. This figure display for copper, fiber optic, and wireless. It is enabled to physical layer interoperability. All aspects of this function are governed by standard organization. The physical layer standards. This is the physical that are implemented in hardware and governed by the organization including the ISO and IEEE and ANSA or ANSI. Next, the functions. The function is the physical components and encoding. The bandwidth. It is a different physical media support the transfer of bits at different rates. Data transfer is usually discussed in terms of bandwidth and throughput. What is throughput? It is a measure of the transfer of bits across the media over a given period of time. Let's proceed to the physical layer terminology or the activity that we are going to do. First one is the term and the physical layer description. Media that use patterns of microwaves to represent bits. It is the um, wire. The capacity of a medium to carry data. It is a bandwidth. Media that use patterns of light. It is the fiber optic. A measure of the transfer of bits across the media. The throughput. Media that use electrical pulse to represent bits. It's copper. Let's check. It's all correct. Let's proceed to the second one, activity. The copper media. This is the unshielded and the twisted and the coaxial cable. These cables are used to interconnected nodes of LAN and infrastructure devices such as switches, routers, and wireless access points. Each type of connection and the accompanying devices has cabling requirements stipulated by physical layer standards. The first one is the unshielded twist pair. It is the UTP or cabling is the most common networking media. The UTP cabling terminated with the RJ45 connectors is used for interconnecting networks hosts with intermediate networking devices such as switches and routers. The coaxial cable, it is the coax for short, gets its name from the fact that they are going to conductors that share the same axis. As shown in the figure, this is the N-type, F-type, and the BNC. Copper media safety. This is the hazards that we are going to um, may be flammable or produce toxics. This is the activity, the copper media characteristics, instruction, UTP, STP, and the coaxial copper media characteristics are provided in the table. Click the appropriate field to match the characteristics to the media type. The first one is the touch antennas to wireless devices can be bundled with fiber optic cabling for two-way data transmission. It is the coaxial. Counters AMI and RFI by using shielding techniques and special connectors, the STP, because of the shielding. The most common network media is the UTP. Terminates with BNC, N-type, and F-type connectors is the coaxial. Let's check. It's all correct. Let's proceed to the next one. The properties of fiber optic cabling. This is the fiber optic cable transmit data over longer distance in the hot and at higher bandwidths than any other networking media. This is the design of the composed of glass or the protective outer shielded. First one is the jacket. Second one is the strengthening materials, the buffer, cladding, and the core. Types of fiber media. It is the single mode. This is a single mode that have a small core, less dispersion, suits for long distance application, or the single mode fiber or SMF. Consists of very small core and uses expensive laser technology to send a single ray of light. The second one is the multi-mode or the large core than single mode cable. It is consists of or use LED emitters to send light pulse. Fiber optic connectors. It have a variety or the types of connectors. The SD connector, SC, LC, and duplex multi-mode LC. This is the connectors. This is the testing fiber cables. Fiber versus copper. This is the activity, the fiber optics terminologies. The instruction, description of fiber optics media are provided in the table. Click the appropriate field to match the description to the fiber optic cable type. First one is the multi-mode or the you can choose the multi-mode or the single mode. The first one is can help data travel approximately 1.24 miles or 2 km. It is multi-mode. Uses light emitting diodes or the LED as a data light source transmitter. From the word LED is a multi-mode. Uses laser in a single stream as a data source transmitter. From the word single stream, it is a single mode. Used to connect long distance telephony and cable TV application. Um, from the word long distance is the single. Can travel approximately 62 miles or 100 km. It is a single mode. And the other one used within a campus network. It is a multi-mode. Let's check. It's all correct. Let's proceed to the next or the last activity. The frame. It is a data link layer prepares a packet for transport across the local media by encapsulating it with a header and a trailer to create a frame. It is a frame. A frame field. This is the header, the packet, the trailer. The frame start and stop indicators used to identify the beginning and the end limits of the frame. The first one is the addressing. Addressing indicates the source and destination nodes on the media. The second one is the type. Identifies the three-layer protocol in the data field. The third is the control. And it identifies special flow control services such as a quality of service. And the data contains the frame or payload, the packet header, segments header, and the data. And the last is the error detection. Is the this field or these frame fields are used for error detection and including of the data to the the trailer. Okay, this is the activity that we're going to do. This is the part one. Generic frame fields. Drag the generic frame fields to its correct location on the diagram. In the first diagram, this is the header. The second one is the packet or the data. The next one is the trailer. So we're going to have a frame start, also the frame stop. The first one is the addressing. The second one is the type. Next is control, the data, and the error detection. Let's check. It's all correct. From the part 2, the generic frames fields also, you can drag it, the term and the description. The first one is that contains the IP header transport layer PDU on the data. It is a data. Identifies the layer 3 protocol used by LLC from the word layer 3. It is a type. Marks the end of the frame stop. Identifies the source and destination. It is an addressing. And the last is the control. The specifies special flow control services. Let's check. It's all correct. Now we're going to have a summary. The summary is the OSI physical layer provides the means to transfer the bits that makes up a data link layer frame across the network media. The physical components are the electronic hardware devices, media, and the other connectors that transmit and carry the signals to represent the bits.